The question number 21 is a compound microscope. If the objective produces image IO and the eyepiece produces an image IE, then these are the four options. And see, when you take this is the objective and this is your eyepiece, and the first image is formed. It's a real when the object is just situated outside the focal length, and the second image is created by this eyepiece is a virtual one. So your image by the objective is real enlarged and by the eyepiece is virtual inverted. So look at the option that I is real and I is virtual is the correct option. So answer to this question is second one. Question number 22 says that in Young's double slit experiment, the intensity of light at a point on the screen with the power difference lambda is k, then intensity at the point on the screen where power difference is lambda by 6 and lambda is wavelength of light. Now dear student, where path difference is 0 and lambda, the intensity will be maximum. In general formula, intensity is equal to, this is I plus 2I and cos of phi, that become equal to 4I cos square phi by 2 by taking both of equal sources. Now maximum intensity is 4I and this is given equal to K. So I maximum is equal to K, which is equal to 4I. Now when the power difference is lambda by 6, power difference lambda by 6 corresponding to phase of pi by 3, and therefore the intensity at that point will be equal to 4 into I and cos square phi is pi by 3, so this become pi by 6. So this is 4I and cos square by 30 degree is equal to root 3 by 2 whole square, and that is equal to 4I by 4 into 3, and 4I was equal to K, so this is equal to K into 3 by 4. So correct answer is option number 3 to this question. Question number 23 is that Heisen's principle of secondary wavelets can be used to deduce the law of reflection of the light, deduce the law of refraction of the light, explain the transfer nature of light waves, and predict the location of wavefront as time passes. Now dear student, it's a geometrical construction, so this is the true statement. And deduce the law of refraction and reflection you have read, but he thought it is a longitudinal wave. So answer third is the C option is wrong option. So your answer goes to ABD. So therefore answer to this question is 3. The question number 24 is a uniform metallic rod rotates about its perpendicular bisector with constant angular velocity. If it is heated uniformly to raise its temperature slightly, then these are four options: speed of rotation increases, speed of rotation remains same, speed of rotation decreases, angular momentum decreases. Now dear student, this was the rod and this rod was rotating about this axis and there was no torque acting, but you have given it a heat. As you give it heat, it expands. So as it expands, its length will increase, so its moment of inertia will increase. Now as the torque acting is equal to 0, so I omega should remain constant. Now what happens that if this is initial I, now in this case I has gone up, therefore omega should decrease. So its angular speed decreases. So answer to this question is 3 option. The question number 25 is a geyser heats water flowing at a rate of 3 liters per minute from 27 degrees Celsius to 77 degrees Celsius. If the geyser operates on the gas burner, the rate of consumption of fuel will be, the heat of consumption is given 4 into 10 to the power 4 joule per gram. Now see, the water is taking heat and heat per minute taken by the water, this is the per minute I am taking, the mass which is 3 liter, so 3000 gram into the specific heat, that is 4.2 joule, and the temperature change 77 minus 27. So this is the heat required per minute. So this is 3000 into 4.2 into 50. Now how much heat is given? On 1 gram of the fuel, the heat you get is equal to 4 into 10 to the power 4 joule from 1 gram. So if you burn the fuel so that this heat become equal to this, so heat should be equal to the mass burnt into the heat from 1 gram. So equate these two, you'll get the mass burnt per second. So delta M into 4 into 10 to the power 4 is equal to 3000 into 4.2 and multiply by 50. You get the mass in gram. So delta M comes to be 15.75 grams, and that is obviously per minute. So answer to this question is the first option. Answer is 1 to this question.